The year is 2050. Above you, a pale, salmon-coloured sky stretches across the horizon. The ground beneath your feet is a rusty red, littered with rocks and dust. You are on Mars, a pioneer in a new world. This is no longer science fiction, but a potential reality as humanity sets its sights on becoming a multi-planetary species. The red planet, once a distant symbol of the unknown, is now the next frontier in human exploration and settlement. The journey to Mars has already begun. Robotic explorers like NASA's Perseverance rover are tirelessly roving the Martian surface, sending back invaluable data about its geology, climate and potential for past life. Private companies like SpaceX, driven by the vision of Elon Musk, are developing spacecraft specifically designed for interplanetary travel, with the goal of making humans a multi-planetary species. The public imagination is equally captivated. Movies, documentaries and books about Mars have become increasingly popular, reflecting a growing awareness and excitement about the possibility of one day living on the red planet. Educational programs and initiatives are inspiring the next generation of scientists, engineers and astronauts who will make this dream a reality. Before humans set foot on Mars, robotic explorers serve as our eyes and ears, diligently scouting the terrain and unraveling the red planet's mysteries. These sophisticated machines, marvels of engineering and human ingenuity, are paving the way for human exploration, gathering crucial data that will inform future missions and guide our understanding of this alien world. Among the most prominent robotic pioneers is NASA's Perseverance rover, a car-sized laboratory on wheels that touched down on Mars in 2021. Perseverance is tasked with searching for signs of ancient life, studying the planet's geology and climate, and collecting rock and soil samples for a future mission that will return them to Earth. Equipped with a suite of scientific instruments, Perseverance is a testament to human ingenuity, exploring the Martian surface with remarkable precision and endurance. The robotic explorers on Mars are on a quest to unlock the planet's deepest secrets, piecing together the history of a world that may have once harbored life. Through their tireless exploration, they are revealing a planet shaped by ancient oceans, volcanic eruptions and dramatic climate shifts, a story etched in the rocks, canyons and polar ice caps of this enigmatic world. One of the primary objectives of these missions is to search for signs of past life, seeking evidence that Mars may have once been habitable, perhaps even teeming with microscopic organisms. Perseverance, with its ability to drill into Martian rocks and collect samples, is at the forefront of this search, exploring ancient lake beds and river deltas where evidence of past life may be preserved. While robotic explorers can accomplish remarkable feats on Mars, their capabilities are limited. To truly delve into the mysteries of the red planet, scientists need to get their hands on Martian samples, bringing pieces of this alien world back to Earth for in-depth analysis with sophisticated laboratory equipment. This ambitious goal is driving the development of sample return missions, complex endeavors that involve multiple spacecraft and intricate maneuvers. The Perseverance rover is already playing a crucial role in this effort, carefully collecting and caching rock and soil samples in sealed tubes, ready for retrieval by a future mission. Traveling to Mars, a journey of millions of miles across the gulf of space, presents a monumental engineering challenge. The spacecraft that will carry humans to the red planet must be capable of withstanding the rigors of deep space travel, protecting its crew from radiation, and safely landing on the Martian surface. Leading the charge in this technological frontier is SpaceX, the private space company founded by Elon Musk with the ambitious goal of making humans a multi-planetary species. SpaceX's Starship, a fully reusable spacecraft designed for interplanetary travel, is being developed with Mars in mind. This towering behemoth, capable of carrying up to 100 people, represents a significant leap forward in spacecraft design, promising to make Mars travel more accessible and affordable. Surviving on Mars, a planet with a thin atmosphere, extreme temperatures and relentless radiation, requires more than just a spacecraft. It demands a home away from home, a habitat designed to protect and sustain human life in this alien environment. Designing habitats for Mars presents unique challenges. Radiation shielding is paramount, requiring innovative materials and structural designs to protect inhabitants from harmful cosmic rays. Temperature control is another crucial factor, as temperatures on Mars can fluctuate wildly between day and night. Habitats must be designed to withstand these extremes, maintaining a comfortable and livable temperature for their occupants. Breathing, eating and drinking, basic necessities we take for granted on Earth, become complex challenges on a planet like Mars. Sustaining human life on the red planet requires replicating Earth's life support systems, creating a closed-loop environment that can provide breathable air, clean water and nutritious food, all while minimizing reliance on Earth-based supplies. Oxygen generation is paramount. While the Martian atmosphere does contain some oxygen, it is far too thin to support human life. Future missions will need to employ technologies that can extract oxygen from the Martian atmosphere or generate it through other means such as electrolysis of water. Carbon dioxide removal is equally important, as human respiration generates CO2, which can be toxic in high concentrations. Establishing a human presence on Mars demands more than just transporting technology from Earth. It requires adapting to the unique challenges and opportunities of the Martian environment, fostering a spirit of Martian ingenuity. This means developing new technologies, utilizing local resources, and finding innovative solutions to the problems of living and working on another planet. One area of focus is in-situ resource utilization, or ISRU, the practice of using locally available resources to support human activities. Mars possesses a wealth of resources that can be utilized, reducing reliance on Earth-based supplies. Water ice beneath the surface can be extracted and purified for drinking, agriculture and oxygen generation. The Martian atmosphere, though thin, contains carbon dioxide, which can be used to manufacture methane fuel and other useful materials. The first human missions to Mars will be tentative steps, short stays focused on exploration and scientific research. Yet the ultimate goal is far more ambitious: to establish a permanent human presence on Mars, a self-sustaining colony that can thrive and grow independent of Earth. This vision of colonization, once confined to the realm of science fiction, is now a tangible goal driving innovation and international collaboration. Building a permanent foothold on Mars requires overcoming numerous challenges. The thin atmosphere, extreme temperatures, and lack of a global magnetic field pose significant threats to human health and require innovative solutions for habitat design and life support systems. Resource scarcity demands efficient utilization of local resources, minimizing reliance on Earth-based supplies. Long-term survival on Mars hinges on the ability to utilize local resources, reducing dependence on Earth and paving the way for a truly self-sustaining colony. This concept, known as in-situ resource utilization, or ISRU, is central to the vision of Martian colonization. It involves identifying, extracting, and processing Martian resources to create everything from building materials to breathable air and rocket fuel. Water is the lifeblood of any settlement, and Mars, though seemingly arid, possesses a surprising amount of water ice locked beneath its surface. Accessing and utilizing this resource is crucial. Technologies are being developed to extract water ice, purify it for consumption, and even split it into hydrogen and oxygen, the former for fuel and the latter for breathing. A true Martian colony will not just survive, it will thrive. It will need to produce its own food, nurture its own ecosystems, and create a sustainable way of life adapted to the unique challenges and opportunities of the Red Planet. This vision extends beyond mere habitation. It envisions the birth of a new world shaped by human ingenuity and the Martian environment. Growing food on Mars is a necessity for self-sufficiency. Traditional agriculture is impractical in the Martian environment, but hydroponics and aeroponics, methods of growing plants without soil, offer viable solutions. These systems use minimal water and space, ideal for the controlled environments of Martian habitats. The journey to Mars and the prospect of inhabiting its rusty plains are endeavours fraught with challenges. One of the most formidable and invisible threats lurking on this alien world is radiation. Unlike Earth, with its protective magnetic field and thick atmosphere, Mars offers little natural shielding from the relentless bombardment of cosmic rays and solar flares. This constant exposure poses significant risks to human health, potentially leading to cancer, DNA damage, and other health complications. The thin Martian atmosphere, about 1% as dense as Earth's, provides minimal protection from high-energy particles originating from the Sun and deep space. These particles can penetrate spacesuits and habitats, posing a constant threat to astronauts. Solar flares, sudden bursts of intense radiation from the Sun, present an even greater danger, potentially delivering lethal doses of radiation in a short amount of time. Venturing into the vast expanse of space, far from the familiar comforts of Earth, presents not only physical challenges but also profound psychological ones. The human mind, accustomed to the rhythms of Earth and the constant presence of other humans, must adapt to the isolation, confinement, and sensory deprivation of a Martian mission. This psychological toll, often overlooked amidst the technological marvels of space travel, is a critical factor that must be addressed to ensure the success and well-being of future Martian explorers. The isolation of space travel begins during the long journey to Mars, confined within a spacecraft millions of miles from home. Once on the Martian surface, the isolation becomes even more pronounced. Communication with Earth is delayed by several minutes, creating a sense of disconnect and limiting real-time interaction with loved ones. The absence of familiar sights, sounds and smells, the constant presence of the same crewmates, and the lack of natural sunlight all contribute to the psychological strain. The pursuit of Mars, while fueled by scientific curiosity and the grand vision of expanding humanity's reach, comes at a steep price. The financial resources required for such an ambitious undertaking are astronomical, involving the development of cutting-edge technologies, the construction of massive spacecraft and infrastructure, and the sustained support of human life in one of the most hostile environments imaginable. This raises questions about the economic feasibility of Mars exploration and colonization, particularly in a world grappling with pressing issues such as climate change, poverty, and resource depletion. The estimated cost of sending humans to Mars varies depending on the mission's scope and complexity, but it is undoubtedly a multi-billion, if not trillion-dollar endeavour. Developing and testing new spacecraft, life support systems, and habitat technologies require massive investments in research and development. The logistics of transporting humans and supplies across millions of miles of space are incredibly complex and costly, requiring the development of reusable spacecraft and innovative propulsion systems. The timeline for human exploration and eventual colonization of Mars is a subject of much speculation and debate. It is a journey that will unfold in stages, each building upon the successes and lessons learned from the previous one. The path to becoming a multiplanetary species is not a sprint, but a marathon, requiring sustained commitment, technological innovation, and international collaboration over a time frame spanning decades, if not centuries. In the near term, perhaps within the next decade or two, we can anticipate witnessing the first human footprints on Martian soil. These initial missions, spearheaded by government agencies like NASA and private companies like SpaceX, will likely focus on short-duration stays, primarily dedicated to scientific research and exploration. These pioneers will lay the groundwork for future missions, testing technologies, conducting experiments, and gathering invaluable data about the Martian environment. The endeavour of reaching and inhabiting Mars is a testament to the power of human collaboration, demanding a concerted effort from the brightest minds across the globe. This grand vision transcends national borders, requiring the pooling of resources, expertise and technological prowess from nations around the world. International cooperation is not just an aspiration, but a necessity for overcoming the immense challenges of space exploration and ensuring its long-term sustainability. Space agencies like NASA, the European Space Agency, Roscosmos and others are already engaged in collaborative efforts, sharing data, coordinating missions and developing technologies for future Mars exploration. The International Space Station stands as a shining example of what can be achieved through international partnership, demonstrating the feasibility and benefits of working together in the pursuit of a common goal. The pursuit of Mars is not merely a scientific endeavour or a technological challenge, it is a profound statement about the future of humanity. It reflects our innate desire to explore, to push the boundaries of what is possible, and to secure the long-term survival of our species. By becoming a multiplanetary species, we are not abandoning Earth, but rather hedging our bets, ensuring that humanity's fate is not tied to a single planet. Earth, our pale blue dot, faces numerous challenges, from climate change and resource depletion to the ever-present threat of asteroid impacts. While we must strive to protect and preserve our home planet, establishing a presence on Mars provides a backup plan, a safeguard against existential threats that could potentially wipe out humanity on Earth. It is an insurance policy for our species, ensuring that our legacy, our knowledge, and our spirit of exploration will endure even if Earth faces a catastrophic event. The quest to reach Mars is a profound reflection of humanity's enduring spirit of exploration, our insatiable curiosity, and our relentless drive to push the boundaries of what is possible. It is a testament to our ingenuity, our resilience, and our ability to overcome seemingly insurmountable challenges. But perhaps more importantly, the pursuit of Mars serves as a powerful mirror, reflecting back to us both the best and the worst of humanity. On one hand, the effort to establish a human presence on Mars highlights our capacity for cooperation, innovation, and selflessness. It requires the combined efforts of scientists, engineers, astronauts, and countless others, all working together towards a common goal that transcends national borders and ideological differences. It demands that we push the limits of our technological prowess, developing innovative solutions to the challenges of living and working in one of the most hostile environments imaginable. And it calls upon us to act as responsible stewards, ensuring that our exploration of Mars is conducted in a sustainable and ethical manner. The year is 2050. A young child born on Mars gazes up at the night sky, a sky ablaze with stars, unfiltered by any atmosphere. To them, Mars is home, a world of red dust, towering volcanoes and endless possibilities. They dream of exploring the canyons of Valles Marineris, of climbing the slopes of Olympus Mons, of unraveling the mysteries still hidden beneath the Martian surface. They are the children of a new world, a world born of human ambition, ingenuity and a relentless pursuit of the unknown. The journey to Mars is not just about escaping the confines of our planet. It is about expanding the horizons of human potential. It is about pushing the boundaries of our knowledge, testing the limits of our technology, and inspiring future generations to dream bigger and reach further than we ever thought possible. It is about ensuring the survival of our species, not by clinging to a single planet, but by venturing out into the cosmos and embracing the challenges and opportunities that await us among the stars.